There, in today's tumultuous times, lies a trend within the car engine industry. In the last few decades, we've seen automakers shift slowly from regularly putting in big V6s, V8s, and even V10s in their cars to instead smaller direct injection engines, with some even fitted with big turbos in sports compacts. All this is because direct injection has benefits including superior fuel economy, better ignition timing, and lower carbon emissions to meet environmental laws such as Euro 6. But there's an ominous force that has been the Achilles heel of direct injection engine design for decades, and we call this carbon buildup. A sickness that, if left untreated, can potentially kill your car's performance and eventually your engine. Do you want to know what it is and how to tell if your car suffers from carbon buildup and why it happens? Stay tuned for the next sections where we'll cover everything you need to know about carbon buildup. With all that out of the way, let's begin. You're having a long day at work, so you and your co-workers decide to unwind by having a few too many beers. The next day, you wake up hungover and feeling your throat all clogged up with mucus. Mucus in your throat is just like carbon buildup, clogging your intake valves, combustion chambers, and injectors. If left unmaintained to the point where chunks of that carbon actually break off, or it is way too clogged up with carbon, this can lead to a host of problems in the long run for all types of car commuters. Before we delve into these problems, we need to first determine how you can find out whether your car is direct injection or not. You can go to the online car marketplace relevant to your country to check the fuel section within the car specs, and it will tell you if it's direct injection within the fuel delivery subheading. Right, back to why carbon buildup sucks. If you're a non-car enthusiast, the issues for you regarding carbon buildup would be limited to decreased fuel economy, engine knocking, which can lead to reduced engine reliability if left unattended, and engine startup due to carbon deposits on fuel injectors disrupting fuel delivery. And if you're a car enthusiast that does care about extracting peak performance, carbon buildup negatively affects that, as it disrupts airflow, leading to an inconsistent air-fuel ratio, which can cause hot spots within the engine's combustion chamber. These hot spots, where carbon buildup lives, can result in overheating, which can hurt your engine's power output and response. This gets worse when we start talking about turbocharged engines fitted with direct injection. Turbo engines operate at a higher pressure than naturally aspirated engines, given they make a specific PSI or bar of boost on top of the atmospheric pressure already provided by the air intake. This makes them more prone to carbon buildup on not only the engine internals, but also the turbocharger components such as turbine blades and wastegates. As a car enthusiast, this sucks even more and becomes a double whammy, where you now have to deal with less than optimal turbocharger performance on top of that already sluggish engine response you feel. Let's now pinpoint how to tell if your car is experiencing carbon buildup. Let's revisit the title of this video, The Silent Sickness of Modern Engines. Well, that's basically how carbon buildup is like, slowly and subtly presenting itself in various ways, until it strikes that deadly knockout punch if left untreated for way too long. Let's list these various ways in the form of symptoms, so you don't get stuck in the middle of the highway wondering what went horribly wrong. These can include more smoke or even black smoke coming from the exhaust system, rough idling and hard startups, slower acceleration, and an overall sluggishness to the engine response. Excessive exhaust smoke or black smoke is the most indicative of carbon buildup, as the engine's inability to properly burn fuel will lead to unburned fuel being released into the air, depending on how faulty your catalytic converter is. The other symptoms though could be symptoms relating to other issues in the car. For example, with a hard startup or overall sluggishness, that could be either due to faulty spark plugs or poor stock ECU tuning. But if you just had your spark plugs changed, or your car when newer felt linear, responsive and consistent, and you still had these symptoms, it's probably carbon buildup. If you want to confirm your fears, let's check under the hood. Make sure to have a trusted mechanic or service technician by your side, or if you're skilled enough, yourself, because this is going to get greasy and dirty. Simply remove your engine cover if you have one and visually inspect your intake valves to check for carbon buildup. If your intake valves are clean, like on the left, they will not have any black residue living on the valve bottoms, meaning no carbon deposits are clogging up the engine. However, if there is black soot situated like in the right image, it's time now to ask the big questions. Why is this happening to me? And how can I fix it? Stay with me as I discuss first conditions which cause carbon buildup. We started this video by specifying that modern direct injection engines suffer from the sickness known as carbon buildup. But why does that apply to direct injection specifically? This is because in direct injection engines, fuel is sprayed right into the cylinder using high pressure injectors, unlike the old carbureted and port fuel injection engines spraying fuel into the intake valves, where the gasoline itself acted as the cleaning agent for the intake valves, preventing carbon buildup. However, in direct injection, we don't see any fuel actually enter the intake valves, so carbon buildup is far more likely to occur in this scenario. As we mentioned just now, the high pressure injectors are involved. Direct injection engines often operate in high heat and pressure, so when this fuel interacts with these conditions, the inevitable carbon buildup can occur. In fact, a study conducted by SAE in 2011 found that direct injection spark ignition engines had at least 10 times more carbon buildup than older port injection engines, and these carbon deposits contain harmful inorganic elements such as calcium, molybdenum, zinc, phosphorus, and sulfur. Another mechanical cause of carbon buildup will be related to your exhaust gas recirculation valves. These EGR valves, as the name suggests, recirculate exhaust gases to the engine intake manifold and valves to reduce combustion temps and emissions. The issue here is as these exhaust gases are dirty and include carbon particles, soot, and oil residue, these will eventually appear as carbon buildup, as we are also dealing with direct injection engines that inject a rich air-fuel mixture right into the cylinder. Let's now talk about what PCV is, known as positive crankcase ventilation. It's a part of the engine's emission control system, and in a similar fashion to EGR, but instead from the crankcase, redirects gas that we call blow-by back into the intake manifold so that it is burnt properly during the combustion process. But you might wonder, are these gases dirty, and can it lead to carbon buildup anyway? Well, it depends. If the PCV system is either designed or functioning properly, then it will manage the flow of the blow-by in a way where the PCV valve stops these oil vapors that can thicken into carbon deposits inside the intake system. Unfortunately, carbon buildup will happen if you have a failing PCV valve or a PCV system that is poorly set up, and this can be a common issue in some direct injection engines such as BMW's N54 and N55 as well as Ford's EcoBoost, where these blow-by gases now turn into unburned hydrocarbons that can thicken into nasty carbon deposits. Excessive oil consumption can also be the culprit of carbon buildup. Large oil consumption can be caused by a myriad of reasons, not limited to poor quality oil, oil leaks, and defective crankcase ventilation, which we touched on just now when we talked about faulty PCV valves. Sensory symptoms associated with excessive oil consumption can include worn piston rings, valve seals or turbo seals, and when this happens, engine oil leaks into the combustion chamber and thickens into nasty black carbon soot due to the high heat within the engine which carbonizes the oil. On top of these factors, using low quality fuel, which is a very tempting thing to do considering how expensive petrol is nowadays, will unfortunately speed up how much carbon is built up in your engine. This is as low quality fuel often contains contaminants that don't burn as cleanly as other premium fuels. So instead, likewise the dirty EGR gases we mentioned earlier, they can form as carbon deposits instead in critical engine internals such as intake valves, injectors, and the combustion chamber. Your driving conditions as well can also cause more carbon to build up in your engine. Have you ever wondered why countries like Vietnam, Thailand, and India have lots of air pollution? That's because traffic in those areas is severely high compared to other areas of the world, and cars in high traffic areas are frequently idling, accelerating, or decelerating, which means the engine doesn't operate at its optimum temperature, leading to incomplete combustion and in turn carbon buildup and poor carbon emissions in the atmosphere. With all that technical talk out of the way, let's now discuss dual injection and how you can avoid carbon buildup in your car. There's a choice you can make if you don't own a car yet, or you're thinking of switching cars in the near future. If you're concerned about carbon buildup and don't want the maintenance niggles of dealing with it, then we can either recommend cars that use port injection engines such as the 2GR FE in my Toyota Orion, or if you're looking for newer cars, look in the direction of cars that use dual injection engines, which is a mix of both port and direct injection. These engines include the European and Australian delivered variant of the 3rd gen EA888, which can be seen in cars such as the Mark 7 Golf GTI, Golf R and the Audi S3, the 3-cylinder G16E GTS fitted to the GR Yaris and GR Corolla, and the FA24D that powers the new GR86 and BRZ. How does dual injection work, you may ask? Well, basically in situations where the engine is not at optimum temperature, either at idle or in stop-start traffic, port injection will be used. However, at high loads such as highway driving or hard acceleration, direct injection instead will be used, as we want the intake valve cleaning action of port injection and the performance and efficiency of direct injection. This is a great way to have the best of both worlds with very few compromises. Compromises might be cost, complexity of repairs, and the lack of engines offering this technology, but it's worth it in our eyes. Now say you own a car that has direct injection only, not dual injection or port injection. Your first line of defense against bad buildup is going to be what we call preventive maintenance. Usually, this term gets thrown around when talking about scheduled maintenance you'll usually get done at either a mechanic or a service center, but these can also include preventive measures such as driving techniques as well as modifications that you can do to your car. Let's first cover a couple ways you can prevent carbon buildup without using a wrench and a few tools. If possible, regular highway driving is great instead of crawling behind traffic. This is as your engine will be operating at a high sustained RPM, improving your air-fuel mixture to ensure complete combustion. However, if your engine is sitting at low RPMs on the motorway, say 2000, then the engine won't be able to generate enough heat to burn off minor amounts of carbon buildup if it already exists. This also helps prevent too much unburned fuel from thickening into nasty carbon deposits. If your engine has been reported by many owners to have a poor PCV design, as mentioned earlier in the cases of the N54 and N55 engines, it would be a good idea to use a driving style that Italian mechanics dub as an Italian tune-up. This involves regularly running the engine at high RPMs under load. And you might wonder, isn't this just regular highway driving? Well, the Italian tune-up involves sustained RPMs as well, but they are usually much higher than normal highway driving, and it will also involve redlining your car by doing hard, aggressive pulls as well. The easiest ways to perform an Italian tune-up can be going hard on your local winding roads or using full throttle and lower gears to keep revs high, which may cause excessive drone compared to regular highway driving's lower sustained RPMs. It should also be done once in a while instead of all the time, unless you're a redline junkie that's come from Hondas. If so, I understand, so you don't stress the engine too much. An Italian tune-up clears the intake valves of any minor amounts of carbon deposits, which, if not resolved, can become a big issue in these PCV prone engines. The common thing with both of these driving techniques as well is the high heat you're able to generate in both scenarios from the engine in order to burn off these nasty carbon deposits. Although it's a much older study from 1994 from SAE as well. Findings were published which showed that when the carbon buildup formed from a spark ignition engine was exposed to temps of 325 degrees Celsius or greater, the high heat actually started to burn off the black soot from the car due to a chemical reaction known as decarboxylation. So now you know why they say a red line a day keeps the mechanic away. We mentioned in the last section how low quality fuel can contribute to carbon buildup. We recommend fuel that is marked as top tier detergent gasoline. What this will help with is cleaning your fuel injectors, and as some of the unburned fuel can fall into the intake valves, carbon buildup is reduced here as this specific type of fuel will have additional detergent additives which can help keep your intake valves and even combustion chambers clean. This type of fuel, before it is marked as so, goes through a series of tests to check deposit control on intake valves, fuel injectors and combustion chambers, as well as checking prevention of intake valve sticking. Using high quality engine oils instead of the stock engine oil is another great way to reduce potential carbon buildup. To ensure you are using the proper oil which is designed to reduce this carbon buildup, you should change it yourself instead of relying on dealer service tech, as usually they will have an oil contract with a specific oil maker such as either Castrol or Valvoline, so you don't really know what oil is in your car. How, you may ask, do I find out which is the best oil for preventing this carbon buildup? You want a thicker and higher viscosity oil such as a 5W30 or even as far as a 10W30, so that it will have lower volatility, which is measured by the NOAC test. This is as lower volatility oil resists the carbonization process, where oil breaks off into carbon bits and eventually sticks into your engine internals. Your car's manual usually will default to putting a thinner and lower viscosity oil, with cars such as the new Subaru WRX suggesting you put 0W20, even though it's a turbocharged direct injection engine. One of the great debates in the deep lore regarding carbon buildup is which is better, a catch can or an air oil separator. Let's discuss. A good quality catch can is placed between the PCV valve and intake manifold as a filter to catch the oil and unburned fuel, so that the intake manifold is not filled with carbon deposits. As a safeguarding measure against carbon buildup, you're going to have to drain this catch can regularly, particularly if you live in colder climates due to the engine not being able to operate at optimum temps as regularly as in hot weather. Every time you install it as well, you need to make sure you're sealing it properly, otherwise you run into vacuum leaks, as the PCV system is always operating under vacuum. On the other hand, if you're busy or lazy and don't want to regularly empty out a can, then consider permanently installing an air oil separator, as, like a catch can, it separates the oil vapors from your air intake. However, unlike a catch can, it's more difficult to keep track of how much oil and unburned fuel is bypassed and carbonized as black soot. Cleaning your injectors in your direct injection engine by using either fuel additives such as WD-40 carb and choke cleaner, or getting a local injector shop to do it for you if you can find one. The reason why we want our injectors clean, especially in the direct injection engine, is so that whatever carbon that has been built up within the injectors as a result of the high pressure and heat within direct injection engines is cleaned up properly to maintain fuel flow and that advertised efficiency which comes with direct injection. Finally, if you love to add high horsepower to your car for either the drag race or to win pink slips at the lights, port injection kits, especially for cars such as the E82 135i, which has the N54, and even the OG M2, which has the N55, are a great way to prevent carbon buildup. Adding a few extra port injectors is going to allow your intake valves to be cleaned properly before that fuel hits the cylinder. Although you might lose a bit of fuel economy, who cares when you have 1000 horsepower? Alright, on to the final but grim part of this video. What to do if you are suffering from way too much carbon buildup. When you have lots of carbon buildup, the best way is just to clean it, and then follow the preventive maintenance above, so it doesn't happen to you again. You're going to first want to remove the intake manifold, so that your intake ports and valves are exposed, as well as close your valves with a socket. That way, you can use either an intake valve cleaner spray or pour valve cleaner into the intake valves and scrape the carbon deposits off manually using a car pick, having let the valve cleaner soak. You can also use walnut blasting, where you basically shoot crushed walnut shells with a medium blaster into the intake valves. The reason why I want to use walnut shells is as they are able to clean and blast off the carbon deposits effectively without damaging the engine's components. Which way is better? Honestly, just use walnut blasting if you can set it up, as it guarantees your intake valves will be cleaned up properly, whilst attempting to scrape all of the deposits off manually is never going to be as precise and efficient. Let's now head into the concluding remarks. Well, that's carbon buildup for you. A silent and stealthy sickness that you don't realize until the symptoms kick in, like VTEC. In some ways, it's a secret the car industry keeps from you, as if a car brand actively outed themselves and confessed the flaw in the engine designs, they'd be opening themselves up to a lengthy lawsuit. Thanks everyone again for the insane and massive growth this channel has had in the last month or so. Keep spreading the love everyone. This really means the absolute world to me, being able to express my passion of cars and engineering to a loyal audience. Thanks again to everyone for tuning in and leaving kind words and incredibly helpful advice in the comments that help improve our videos, and I'll see you in a bit.